want to talk about arithmetic sequences here with you next. An arithmetic sequence, the basic idea behind it is equally spaced. An equally spaced sequence. Here's what I mean. 2, 4, 6, 8, 10. Those are equally spaced. They're the even numbers, but they are equally spaced, right? They're spaced out by 2 each time, right? 3, 7, 11, 15, 19. This was another one I had previously. Those are equally spaced, right? Got a spacing of 2 here, spacing of 4 here. So every time they're equally spaced. That's basics behind it. Now, a more technical terminology here is to say they have a common difference. Common difference, because really an arithmetic sequence is known by, if you will, by its common difference, D. D is what we'll call the common difference. And also note here, so in sequence 1 there, D is 2. Sequence 2, D is 4. Okay? So it's just a common difference, the difference between terms. Now it's also noteworthy here that D, please note, is, well, notation-wise, this is how you see it, but let me just tell you, what this means is the n plus 1 term minus a sub n. So this is, say that's our term, then this is the term before it. So it's term minus the previous term. In other words, to get the common difference, you want to take a term and then subtract the previous term from that. Why do I note that? Well, what about this one? What about 30, 21, 12, 3, negative 6? Are those equally spaced? Yes, they are. But what is the common difference? They're spaced by 9, but more specifically, isn't it negative 9? Yeah. The D here, the difference is negative 9 because, yeah, the terms are decreasing, if you will. They're going down instead of up. And so that's one note there. But, yeah, that's what I'm saying. If you do the difference, you want to do the term minus the previous term. And so that's what gets you the negative 9 there, okay? So just note that. If it is equally spaced and the terms are headed downwards, the difference is a negative. So that's the story on that. Okay? So one thing they'll have you do is just check whether or not the sequence is arithmetic. All right, number 1 here, 9, 17, 25, 33, 41. Is that arithmetic? I think so, yeah. It is arithmetic, and if it is arithmetic, tell them what D is. D here would be 8, wouldn't it? Yeah, they're spaced out by 8. So it's just the spacing is the difference. Okay, number 2. What about 1, 4, we saw this one earlier, 1, 4, 9, 16, 25. The squares. Is that arithmetic? No. Yeah, the spacing there just isn't equal, is it? You got a spacing here of 3, here you got 5, here you got 7. Now there's a pattern there, but it's not 9. Sorry, it's not arithmetic because they're not equally spaced. Not the spacing between them the same each and every time. 3. that one arithmetic? Well, we might want to look, without knowing anything else, we might want to look at some terms, right? What is the first term? First term would be 5, right? Plug in A to be 1, N to be 1. What about the second term? Second term, 6 plus 2 would be 8. Third term, 9 plus 2, that's 11. Fourth term, 12 plus 2, 14. Is that okay? So just those terms alone, what do you think? Yes, it is. Okay. It is arithmetic, because they are equally spaced, with D equal 3. All right, number 4, is this one arithmetic? A sub n equals n squared minus 4. Well, again, term by term, without knowing anything else right now, n squared, 1 squared minus 4, be the first term, which is 1 minus 4, which is negative 3. Second term would be 2 squared minus 4, which is 4 minus 4, which is 0. Third term would be 3 squared minus 4, 9 minus 4, which is 5. Fourth term, 4 squared minus 4, 12. Fifth term, 5 squared minus 4, which is 21. Give us some more, but I think that's enough to say no. Not arithmetic. Okay? One more. Yeah, there's not an equal spacing. This is, what, 3, that's 5, that's 7, so there's sort of similar to number 2 there, but I'll say more about that in just a second. All right, number 5. How about A sub n equals 10 minus 4n? Well, the first term would be 10 minus 4, which is 6. Second term would be 10 minus 8, be 2. Third term would be 10 minus 12. 10 minus 12 is negative 2. The fourth term would be 10 minus 4 times 4 would be 16. That's negative 6. And then the fifth term would be 10 minus 20, which is negative 10. I think that's enough to see. Yea or nay? Yes, arithmetic. And D would be negative 4, yes. Be sure to note negative 4. The terms are decreasing, if you will, but they are equally spaced. This one's negative 4, negative 4, negative 4. Okay. All right. Here's my point. And I even can make it even better here if you think about this one is A sub n equals n squared. Why do you think these two were arithmetic, but these two were not? Do you see a pattern just on the equation, if you will, the generator? This power is power of 1, right? Power of 1. When I get an n squared, same thing would be true with an n cubed, or it has something else, a square root of n or something like that. Yeah, to be arithmetic, the sequence, the generator, needs to be linear. You know what I mean? To the first degree? Yeah. Arithmetic sequences are linear when you write out their equations, if you will, the generator sequence there. Yeah, arithmetic sequences are linear. First degree, first power. First powered sequences. Okay? In other words, their generating sequence is not n squared, it's not n cubed, it's only n to the first power. You can only have your highest power of n being 1. Okay? So that's how you can tell, just by looking, A sub n, whatever you got, A sub n equals, well, if I have n squared minus 4n plus 2, arithmetic? Not arithmetic, is it? Because that's quadratic, second degree, so that one's not going to be arithmetic. Talk about more of this one, but how about that? Is that one going to be arithmetic? No, that's exponential, right? When you have a this one's second degree, n squared. This one's exponential because you've got the variable in the power, and exponential is not linear by any means. There's another way you can think of it. Linear, if you graph these on a graph, be a straight line. That's not going to be a straight line. It'll be one of those hockey stick shapes. So no, that one's not arithmetic. That's what we're saying. Okay? Just by looking at the a sub n equation, you can tell whether it's arithmetic or not. It's linear, first degree, defining expressions. All right? Questions or concerns? Well, another angle on this is the series, arithmetic series. Turns out you don't have to add up all the terms of an arithmetic series to get the sum total of the arithmetic series. There's a formula for arithmetic series, the first n terms. And that's what we're going to talk about next. So the sum of the first n terms of an arithmetic series sequence. Formula goes like this. S sub n, meaning n, sum of the first n terms, is you take the number of terms, n divided by 2, and then multiply a sub 1 plus a sub n. Now, like I said, we're doing the first n term, so n is just the number of terms that we're summing up, and we're going to divide that by 2. Then I'm going to take, what does this mean? A sub 1, that's just the first term. And then a sub n is the last term. That's all you have to do to add up the first n terms of an arithmetic series. If it's arithmetic, that's all you have to do to sum that many terms. 1 through 100? Sure. So if I wanted to add 1 through 100, why not? Let's put 98, 99, and 100 up here. Obviously, I'm not going to write all 100 out there. Okay. Yeah, what this is saying then, that's arithmetic, right? It's got to be arithmetic for this to work. It is arithmetic because they're spaced by ones. Okay. So this is saying then, my S sub n, that's 100 terms, so I have 100 divided by 2, and then I'd multiply that by 1 plus 100. First term plus the last term. So that's 50 times 101, which is 5,050. Right? Did I do that right? 101 times 50? That doesn't seem right. $5,050? 5,000. Okay. For some reason it didn't sound right. So instead of having to add up 100 terms, you just do those. Now, here's why that works. That's a good one to show you why that works. The reason that works is if you pair these up, for example, I'm going to pair the first and the last, pair then 2 with 99, then 3 with 98, and so forth and so on. If I pair them up, how many pairs do I have? There's 100 terms, so there'd be 50 pairs. Okay? And why is it 101? 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So every pair adds up to be 101. So you have 50 pairs of 101. That's why that formula works. Okay? So it's a nice way of doing it. Okay, now, all right, so that's how one like that works. And here's, though, an even better use for it. Well, that was a pretty good use because that was 100 terms. All right, what about this one? What if I have the sum n equals 1 to 70, 6n minus 2? Well, this one is almost like that one. Because I've got how many terms? 1 to 70, that's 70 terms. So I've got 70 terms. I don't want to add 70 terms if I don't have to. Well, it turns out I can use the arithmetic series formula. How do I know I can use it? I mean, it's not necessarily going to be where I could use it. How do I know I can use that formula? The S sub n equals n over 2 times a sub 1 plus a sub n. How do I know I can use that? Well, it's arithmetic, isn't it? How do I know it's arithmetic? Because it's linear. It's n to the first power, okay? If this was the sum 6n squared minus 2, that formula wouldn't work because that's squared. It's not linear. But if it is linear, I can use that formula. All right, so what have I got? Like I said, we got 1 to 70. That's 70 terms, so n is 70. 70 divided by 2. I do have to do a little calculating here because I need the first term. What's the first term here? Well, the first term, plug in n to be 1. So that would be 6 times 1 is 6. Okay, so that'd be 4. Then I need this term. What is that term? It's the last term. So that would be 70. N is 70. So it would be 6 times 70 minus 2. 420 minus 2 is 418. With me on that? So this is going to be, the sum total is going to be 35 times 422. Right? Which is a big number. Pretty big. 14,707. But it's a lot easier doing it that way than all 70 added together. All right? Okay, now take a look at another one here. What about the sum? And this one's going to be k equals 0. And let's do k equals 0 to 44 of 7 minus 8k. Again, it's linear. So again, it's arithmetic. Right? K to the first, so I know it's arithmetic. That is important to know. So I can use this formula. S sub n equals n over 2 times a sub 1 plus a sub n, which is a little misleading in this case, but we'll get to that in just a second. All right. Well, first of all, what is my n? 45. Why 45, not 44? Well, you got to know what you're starting at, right? I'm starting at k equals 0. 1 to 44 would be 44 terms, but I've got an extra term because I'm starting at k equals 0. So there are 45 terms. Divide that by 2. All right, then, yeah, this is a little misleading, a sub 1. It means the first term. Well, the first term here will be with k equals 0. 7 minus 8 times 0, not 8 times 1. So that's just a little notation there. But it does mean the first term. Whatever the first term would be, starting with whatever the index says to start with. So that would be 7. Right? And then we've got the last term, so plug in the 44. 7 minus 8 times 44, which is Pretty big number. I get negative 345. Anybody else get that? Is that what y'all got? Okay. Which brings up a point here, a couple points. 45 divided by 2 is 22.5. That's okay. You can have decimals here. And then also over here, 7 minus 345 is negative 338, isn't it? And when you multiply 22.5 times negative 345, you get negative 77. Negative 338. That's not what you get. 22.5 times negative 338. Negative 7605. Is that what you said? Okay. So, a couple of points there. We do get a negative answer. Why do I get a negative answer? Well, it's because the terms start getting negative, don't they, as far the further out you go. The last term's negative 345, so back up from there. You've got a lot of negative terms. And so, yeah, that makes sense that the sum of them would be a negative number. You're just adding up negative terms. I think just this first term is positive. I think the rest of them would be negative. So that's the other one point. Also, just a little explanation. Why do I have 22.5 there? Well, think about the pairs thing. I don't have a complete pair. There's one of them doesn't have a complete pair with it because there's 45 terms. So that would make sense that I don't have a full whole number of pairings there. So anyway, that's what we get. All right, now, make a quick point about this. What if I had sum I equals 1 to 10, and, all right, let's just do 2i squared. Got to use this formula? Nope. I can't use that formula. I'm actually going to have to, then there's another formula that we'll use, but it's not going to be any good on that one either. But no, I can't use that formula because of the squared, right? This one's not arithmetic, so I can't use the formula. That n over 2, that nice little formula there where I just have to do a few little calculations won't work. So what do I have to do if I don't have another formula that works? Just have to write the terms out, okay? So this is just back to 2 times 1 would be 2, 2 times 2 squared would be 8, 2 times 3 squared would be 18. So just add up all 10 terms. Where am I? 4 squared would be 32, 2 times 5 squared would be 50, 2 times 6 squared would be 72, 2 times 7 squared, 49 would be 98, 2 times, so it takes a little more time, but that's, we have to do it right now. All right, where am I? 2 times 64, right, 128. 2 times 81 is 162, and 2 times 100 would be 200. So yeah, you just have to add them all up. So just make that point there. So you check me on this, but I think I'm going to get 770.